Hey everyone, and welcome back to DevOps Corner. If you've ever spent hours, maybe even days, wrestling with some bizarre Kubernetes error, you know just how frustrating that can be. Well, today we're diving into something that could be a real game changer, k8sGPT. Think of it as an AI sidekick for all your Kubernetes troubleshooting. And hey, if you like what you see, do me a favor and hit that like and subscribe button. It really helps us keep making more content like this for you.
Right? We've all been there. You're staring at your screen, kubectl just spits out some error that makes absolutely no sense, and you just feel that sinking feeling, knowing your afternoon is now booked solid, with digging through logs and endless YAML files. It's just a massive headache for any of us in DevOps or SRE, and that's the exact problem we're going to tackle today.
So what's the fix? Well, what if you had an expert Kubernetes SRE just on call for you 24/7? That's the big idea behind k8sGPT. And this isn't just some fringe tool. The CNCF even highlighted it, which tells you it's something special.
So you might be wondering, how does this thing actually work? Well, this is where it gets really smart. k8sGPT doesn't just blindly throw your errors at a chatbot. No, it's a two-step process. First, it has these built-in analyzers. You can think of them like a digital SRE playbook. They scan for common, known problems. Then, and only then, does it take that diagnosis and hand it over to a large language model, an LLM, to explain it all in plain English and give you real solutions. So you're getting the best of both worlds, structured expert knowledge combined with the power of AI. Okay, so you're probably thinking, this sounds great, but is it a nightmare to set up? Nope. Getting the command line tool up and running is actually super simple. Let's walk through it right now. Seriously, if you're on a Mac or Linux and you use Homebrew, it's just two commands, that's it. First, you're going to brew tap the k8sGPT repository. This just tells Homebrew where to find the package. And then, step 2, you just brew install k8sGPT. Boom, done. The tool is now installed on your machine, ready for the fun part. All right, so the tool's installed, but right now it's like a body without a brain. To get those awesome, simple-to-understand explanations and solutions, we need to connect it to an AI backend. This is literally the GPT in k8sGPT. And you have a ton of options here. You can hook it up to all the big names: OpenAI, Azure, Google Gemini, you name it. But honestly, the most exciting part for me, and probably for a lot of you, is the support for local models. This means you can run the AI entirely on your own machine using tools like Llama or local AI. That's a huge deal. And let's break down why that's so important. When you use a public service like OpenAI, you're dealing with API keys, which means costs. And you're also sending your cluster data out to a third party. Now, with a local LLM, it's totally free. You run it on your own hardware. And most importantly, all your data, all your error messages, everything stays right there on your local system. For privacy, and for just getting started without a credit card, that is an absolute game changer. And here's the best part. You won't have to be some AI wizard to make this happen. Hooking up k8sGPT to a local model you're running with, say a llama, is literally just one command. So you're going to run k8sGPT auth add, then you just tell it what you're connecting to. So dash backend to llama, you pick the dash model, maybe llama 3 if that's what you've pulled, and finally, you give it the dash base URL where your llama server is running, which is usually just on localhost. You hit enter, and that's it. Your k8sGPT now has a brain, and it's running entirely on your machine. Okay, setup is done, we're installed, we're configured. Now for the fun part. Let's see this thing in action. We're going to create a real-world problem and see if we can get that big aha moment. So we're going to break something on purpose. We're going to try and deploy a pod that asks for a ridiculous amount of CPU, like way more than any node in our cluster could possibly have. This is a super common reason why pods get stuck in that dreaded pending state. Here's the YAML for our little troublemaker. We'll call it the hungry pod. And look right there. Under resources.requests.cpu, we're asking for 1,000 cores. Yeah, unless you're running this on some NASA supercomputer, that's just not going to happen. So we apply this manifest, and just as we planned, it's stuck. Pending. Forever. This is that classic moment of frustration, right? Normally, you'd be running kubectl describe pod and trying to decipher what those event messages are even trying to tell you. But let's try the k8sGPT way. Okay, first step, we just run k8sGPT analyze.
Super simple. This is just using those built-in SRE playbooks we talked about. The AI isn't even involved yet. And bam, right away, it finds the issue with our hungry pod. The error is insufficient CPU. Now, this is already way faster than digging through describe output, but let's be honest, it's still a bit technical. It tells us the what, but not the why or how to fix it.
Okay, now for the magic trick. We're going to run the exact same command, k8sGPT analyze, but this time we add one little flag, -explain. This is the signal. This tells k8sGPT, okay, take that technical jargon and send it over to the AI brain we connected earlier.
And look at this. This is the payoff. We get a simple, plain English explanation. The pod is asking for more CPU than any node has, but it doesn't stop there. It gives us 3 potential solutions. We can either lower the pod's CPU request, add a bigger node to the cluster, or maybe free up resources by scaling down other things. It's not just telling you what's broken, it's giving you a roadmap to fix it. This is exactly what a senior engineer would do.
I mean, that alone is worth the price of admission, which is free. But k8sGPT has even more features packed in that make it a true powerhouse, especially when you're working in bigger, more complicated setups. For instance, you can use filters to zero in on a specific namespace instead of scanning everything. If you are using a public LLM, there's a killer anonymization feature that strips out sensitive names before sending data. It also integrates with other tools, like the Trivi scanner, to check for vulnerabilities. And the one that really gets me excited is the experimental auto-remediation feature, a little glimpse into a future where these tools might just fix problems for us. So when you step back and look at the whole picture, it's clear. k8sGPT isn't just a troubleshooting tool. It really is like having an AI sidekick with you in the trenches of Kubernetes.
So why does any of this matter? Well, first, it saves you an incredible amount of time. Less time debugging means more time building. Second, it basically democratizes knowledge. It gives everyone on the team access to expert-level insights. It also helps you build more reliable systems by catching things you might have missed. And honestly, it's an amazing learning tool. By explaining the why behind errors, it actively makes you a better engineer. And that's our deep dive into k8sGPT. I really hope you found this useful. If you did, please do me a huge favor and hit that like button, and maybe share this with your team. Thanks so much for hanging out with us on DevOps Corner.
I'll leave you with one last question to chew on. Today, we saw an AI that can diagnose problems and tell us how to fix them. But what's next? With features like auto-remediation on the horizon, what happens when your Kubernetes cluster can just heal itself? Think about that. The future is definitely going to be interesting.